With this video, we're going to go through the entire lesson of solving these systems of equations with three different variables. So this one's going to be a little bit more of a lengthy video, but hopefully it will help as you go through it. The whole goal of what we're going to do with this lesson is to solve a system. It will have three different variables. Typically, the most ones you see are x, y, and z. Sometimes we'll do some a, b, and c, and some r, s, and t, but basically it's got three variables. We've solved two variable equations in the past. And so we're going to build on that a little bit, but first let's get just a little bit of review. So I've got these two systems of equations here. You need to be proficient in solving these before you go on to the next step. So I want you to go ahead and solve both of these. I want you to solve number 1 for x and y and number 2 for b and c. So go ahead and push pause on the video now after you've obtained your answers, and come back and push play to check to make sure you get the right answer. Okay, check your answers here. Alright, now on these, we wanted to eliminate our y, so we multiplied the bottom equation, this equation number 2, by a multiple of 2. And that allowed me to eliminate my y's. Okay, so you should be pretty good on this at this point. Get one more practice just to make sure you've got it down. Push pause on the video now, and then work through your answers after you've obtained your solution, then come back and push play. Check your answers here. Okay, so we can solve these types of equations if it has two variables. You'll end up having two equations with two variables. We can add these together to eliminate a variable. That's what we did here. By the time we multiply these, we could add these two together to eliminate my x's. Then we could just solve for y and plug it back in to find our x value. Well, we're going to be doing something very similar to that. The only difference is now we're going to have three variables. So instead of just an x and a y, we're going to have an x, y, and a z. Okay, so it's going to be a very, very similar process, just going to be more lengthy is really what it's going to boil down to. Our whole goal when we're doing this one, if we go back, I'm going to go back to this one. These have two variables, two equations with two variables, and we can solve those. We've been doing those. So the new one here, let me fast forward, here we go. The new goal is to reduce this down to two equations with two variables, because that's just like the one that we just did. So if we can get it down to that, we already know how to solve those. So we're going to use almost an identical process. This looks pretty daunting because we have three equations here, three different variables, but really we're just doing the same thing. We want to look here and see if there's any one of these that we can easily eliminate. I've got an x and an x here. This one's a 3x. The x's aren't too bad. Z's, I've got a 3, a 1, and a 5. That doesn't really look very good to me. But if you look at your y's, I've got a lot of these that are already the same. I've got all of these are 2's. One of them is negative, the other two are positive. So I'm going to work to eliminate my y's here. Because if I eliminate my y's, I can get just x's and z's. And if I have just x's and z's, those are just like the problems that we just did. So what I'm going to do now is I'm going to add these equations together. I'm going to add, we'll start with this one, 1 and 2. And I'm going to eliminate my y's here. Okay, so there's equation number 1, there's equation number 2. And I simply add the two together. So x plus x gives me 2x, my negative 2y plus 2y gives me 0, so we leave that off. And then 3z minus z gives me 2z, and 1 plus 13 is 14. Okay, so this is one equation with two variables. So far so good. Now I'm going to write this one up here just so I have some room. It's the same equation, I just wrote it up here. I'll need the whole page here to go through it all. Now, so I added numbers 1 and 2 together. Well, I need to eliminate my y, and I need to incorporate this equation number 3 here. I can't add 1 and 2 together again. I just did that, so I already know what that one is. I need to get something that's different. I could add equations 2 and 3. However, I have a 2y and a 2y. When I add those together, I get 4y, so that doesn't help much. So instead, what I'm going to do is add equation number 1 and equation number 3 together. If I add those two together, I can eliminate my y. So I've got equation number 1, I wrote that down here, and equation number 3. Now when I go through and I'll add these two together, my y's will disappear. So I've got x plus 3x gives me my 4x, negative 2y plus 2y eliminates my y's, and that's my goal. So I eliminated y in both of these two. I'm going to end up with two different equations with two variables. Okay, so then I've got a 3z minus 5z is negative 2z, 1 plus 3 is 4. Now, I wrote this one up here. I'm also going to write this one. I'm going to transfer that one over as well, just so that I have more room to work here. In fact, I'm going to need to eliminate all of this just because it's going to take a little bit more time here. So I'm going to move both of these two up here. It's going to be the same exact equations here, but I'm just going to move them up here. So that's all I did, and kind of cleared out some space for me. Again, this top equation here came from right here. The second equation came from right here. So now that I have this, these are just like the ones that we've been solving before. I need to eliminate a variable. Fortunately for me, I didn't have to do too much here. I can just add these two together and eliminate my z's. I've got a positive 2z and a negative 2z. I'll just add these two together. I end up with a 6x. 2x plus 4x gives me 6x. My z's will cancel, and 14 plus 4 gives me 18. I solve it for x. I divide both sides by 6. I find out that x equals 3. Well, if x equals 3, it doesn't help me much to plug it back into here because I still don't know what y equals or z equals. So what I would do here is I'd plug this one back into these equations, one of these two. That way I can solve it and find out what z is. And it doesn't matter which one you choose. You can pick your favorite. I've got the first one is the one that I like. So I write this one down. This is my first equation. Now what I'm going to do is plug in 3 for x. So I rewrite the same equation, but instead of writing x, I'm going to write 3. So this is 2 times x, so in this case it'll be 2 times 3. All right, I simplify that a little bit. 2 times 3 is 6. Now then all I'm going to do is solve this one for z. I move my 6 over to the other side. 2z equals 8. I find out that z equals 4. Okay, well now that I know that x equals 3 and z equals 4, I can plug it into any one of these three equations. It doesn't matter which one, and I can solve it for y. So you got to pick one. I just went ahead and chose the top one because it was listed first, but you could choose either one that you wanted to. Now I'm going to plug in, I know my x value is 3. I'm going to plug that in right here for x. My z value is 4, so I'm going to plug that in right here for z. So I rewrite that one. Now I need to simplify this a little bit further. That's going to be 3 times 4 is 12. I can combine my 3 and my 12. 3 plus 12 is 15. So now I just solve it for y. I move my 15 over to the other side. I subtract 15 from both sides. And then I've got a negative 2y equals negative 14. I need to divide negative 2 by both sides. Find out that y equals a positive 7. So I have x equals 3. That comes from up here. Z equals 4. And y equals 7. And when you write these, especially with the online system, you'll write these essentially as an ordered trio. There will be 3 of them. There will be an x, y, and z. They must be written in alphabetical order. We consider that part of our standard form, but x value, then comma y value, then comma z value, with parentheses around it. This means that this is my x, y, and z. Okay, now these are fairly complex, and this is the first time you've seen it. So I'm going to actually do 2 example problems here before I give you an opportunity to try this one on your own. So here's my second example problem. Okay, now I'm going to look through these, and I can eliminate any one that I want. I've got some z's here. Let's see, 2z minus 2z, but this one looks pretty nice. I've got a 5 here, so it's okay. The y's I could eliminate. That one actually looks like I got a 2y and a 2y here. Then a 4y, I just have to double one. That's not bad. The x's, they look probably the worst here. You could choose to eliminate all your x's, and that would work fine. You could choose to eliminate all your y's, and that would work fine. On this one, just to spice it up a little bit, I chose z. So my goal again is to reduce this down to 2 equations with 2 variables. So I'm going to take my z's and try to eliminate those. First of all, I've got a positive 2z here and a negative 2z here. So if I just simply add equation number 1 and 2 together, I can eliminate my z's. So there's equation number 1. Here is equation number 2. Okay, I got those just from right up here. I'm just going to simply add these together. Negative 5x plus 3x, minus 3x gives me negative 8x. Negative 4y minus 2y gives me negative 6y. My z's cancel out. And then I have a negative 19 and negative 5 give me negative 24. And from here, you can write it wherever you want. I just write it up here so I have some more room, just like I did on the previous problem. Okay, now, I can do anything I want here. And let's see. I can't add these two together again. That's what I just got here. So it needs to either be 2 and 3, or it needs to be 1 and 3. And either one will work. I notice this one's a positive and this one's already a negative, so then I don't have to multiply by a negative. So for that reason, I chose to do equations numbers 1 and 3. You could have done equation number 2 and 3, and that would work as well. All right, so I combine these two together. There's equation number 1. Here's equation number 3. The problem here is my z's don't automatically cancel, which is unfortunate. So now what I'm going to have to do is determine what I'm going to have to multiply the top equation by and the bottom equation by so that these will be able to cancel, my twins, if you will. I need to have the same number on top and bottom, one of them a plus and one of them a minus. So 2 and 5, let's see, the lowest one I can go with is 10. that means I'm going to need to multiply the top equation by 5 and the bottom equation by 2. So I multiply the top equation by 5, and when you do that, you're going to have to multiply every part, the x, the y, the z, and whatever on the other side of that equal sign. So I do that to each part. Now the bottom equation, I multiply the entire bottom equation by 2. And again, I'm going to multiply every part, the x, the y, the z, and the other side of the equal sign, okay? A lot of times students forget to do the other side of the equal sign. That's the biggest error that I see. Okay, well now if you notice here that I've done that, I can get rid of my z's here because I have a positive 10z up top and a negative 10z on bottom. So I'll just add these two together. I add each one of these, negative 25 and 2, give me negative 23x. This will give me a negative 24y. Of course my z's cancel, that was my goal. And then I have a negative 95 plus 26 gives me negative 69. Alright, so now that I've got that second equation, I'll go ahead and write that right next to this one. Because what I'm going to do is going to be combining these. My goal was to reduce it to 2 equations with 2 variables. So I have 2 different equations here, and 2 variables, x and y, are my 2 that I get to keep. And these are just like our other ones that we've practiced. We've been working on these for a while now. I've got these 2 equations. I can either eliminate my x's or my y's, whichever one I think is going to be easiest. In this case, you can look at this and either one will work, but in this case I think the y's would be a lot easier. So if I just simply multiply the top equation by a negative 4, that would give me positive 24y here. I already have a negative 24y on the bottom. I can just add those two together. So I do that now. I multiply the top equation by a negative 4. And remember, you have to do it to all parts. Then the bottom equation will stay the same. I won't change that one at all. Now my y's, these 2 equations I can simply add, which will eliminate my y's. That was my goal. So I'll add these two together. 9x equals 27. So I divide both sides by 9. X I find out equals 3. Well, that's helpful. Now that I know x equals 3, I'm not going to plug it into these equations. It's too much for me yet. I've got to find out what y equals first. So I'll have to plug it into one of these 2 equations. Maybe I can even use one of these 2 equations. It really doesn't matter. As long as you've done your calculations accurately, it won't matter which one you plug it into, of these 2 here or these 2 here. I have to choose one, so I chose that first one there. I plug my 3 in for x. So this is negative 8 times x, so it's negative 8 times 3. I simplify that one, that'll give me a negative 24. So I need to move my 24 over to the other side, so I add 24 on to both sides. I find out that negative 6y equals 0. So in other words, y equals 0. Okay, so this is big. I've got x equals 3 and y equals 0. Now that I know that, I just have to plug these in to find out what z equals. And I can plug it into any of these 3 equations. It doesn't matter which one. Now, I'm going to choose to plug it into that third one. And the reason why is because it didn't have a coefficient up front here. I thought it would be a little bit easier. But again, if you want to plug it into the first one here, that's fine. No worries there. So I'm going to plug in my x value and my y value. I plug in 3 for x. That came from right here. And I plugged in 0 for y. That's you notice how the greens match up. Okay, now I just kind of simplify it a little bit. This is 3 minus 0. And I can combine those two together, so it just ends up being 3. And I'm just going to solve this one for z. I move 3 over to the other side. I subtract 3 from both sides. Negative 5z equals 10. I find out that z equals negative 2. So I've got an x value of 3, a y value of 0, and a z value of negative 2. So my x value is 3, that came from right up here, y value is 0, and by plugging both of those in, I found out that z equals negative 2. So I have to write this as, with parentheses, as an ordered trio. I separate them all by commas, and it goes alphabetically. X comes first, then y, then z. So this would be your answer on this one. Okay, now I'm going to give you a chance to work on these. So let's get a little bit of practice here. Here is your equation. I would like you to push pause on the video now. If you need to, you can rewind the video and go back through and see what I was doing on the previous ones. And that might help out a little bit. But the goal is to reduce these down so that you have 2 equations with 2 different variables. And I'll give you a hint on the first one. Your y's look like it's going to be the easiest. So see if you can eliminate your y's. Now again, you don't have to, but it's going to make your life a lot easier if you do. So push pause on the video now. After you've obtained your answers, come back and push play. Check your answers here. Okay, there's quite a bit to that. If you eliminated your y's, that made your life a little bit easier there. We could quickly identify what the z values were. and it made it really nice because I didn't have to multiply anything here once you brought it over. When I added those two x's together, I've got a negative x and a positive x. My x is automatically eliminated. So that one wasn't too bad. And again, you have to make sure that you write them in the correct order. Remember, it's alphabetical order, so in this case, x, then y, then z. All right, let's get you a little bit more practice on this one. So same thing on this one. You want to reduce it down to two variables, two equations, two variables. Push pause on the video now. After you've obtained your answers, come back and push play. Check your answers here. Okay, hopefully you're starting to get the feel for it just a little bit here. When we brought these two over here, unfortunately, this red and this blue one here, we weren't able just to eliminate them by adding the two together. So that made it a little bit more complex. You could have chosen to eliminate your s's and that would have worked. T's in this case I thought was going to be better, easier. I just multiplied the top one by a -3. And that did it. And check to make sure that you had -60 over here, that you multiplied that -3 to all three components. Okay, and I think this will be our last one, so I'd like you to give this one a try. Push pause on the video now. Then work out your solution. After you've obtained that, come back and push play. Check your answers here. As we're going through this, I think you might need a little bit more practice. Let's try one more before we end it. Try this one. And same thing, push pause on the video now. After you've obtained your answer, come back and push play. Check your answers here. Okay, so there's quite a bit to these. The big thing is just pick one that you want to eliminate. And on this particular one, I chose to eliminate my A's. I thought that would be easier. Some of you may look at this one and go, well, B's were a lot easier to eliminate. And that would be fine if you chose to eliminate your B's. As long as you did all your calculations correct, you'll come up with the exact same answer that I did here. So you can rewind the video, watch it a couple more times. I also have some other videos on similar problems that you can watch as well.